Let's see. The question number 16 has been derived from the topic of wave. Now you see it says that equation of traveling wave on a stretched string of linear density 5 gram per meter. So the linear density is going to help us to calculate the velocity of wave. So here goes the linear density, what you represent by mu or lambda as per the convention you are comfortable with. Okay, and y is there, that's a sine omega t minus of kx, where distance and time are measured in SI units. Fine. So there is no trouble of unit conversion. We need to calculate the tension in the string. Now what I'll do is say, this is omega, this is k. So I can use the expression V equals to omega by k. So omega is there and k is there. You'll calculate the value of velocity. And the same velocity of wave in a stretched string is under root t by mu, where t is the tension and mu is the mass per unit length. So this is given, this is given, this is given. Of course, do not forget to convert it into SI unit. That may be very critical. And now you can easily calculate tension. When you do that, you'll get 12.5 Newton. So correct option stands out to be option number 4. All right, now it's time to move to question number 17. Question number 17, another straightforward question, and that has been put from the topic of kinetic theory of gas. So let's see, what is that question like? A gas mixture consists of 3 moles of oxygen, of course, which is diatomic, and 5 moles of argon, which is monoatomic. At temperature T, considering only translational and rotational modes, that means the vibrational mode isn't to be considered, which is a fair assumption. Now, we need to calculate the total energy of the system. So remember, the question hasn't asked about the energy per molecule. It says the total energy of the system, and we know that is NCVT, where CV is RF divided by 2, F is the degree of freedom. So it goes in this way. If I calculate here, let's start. 3 moles of oxygen, so 3 into CV, which is 5R by 2 multiplied by T, plus the next time it's 5 moles of argon, and this guy is a monoatomic, 3R by 2 multiplied by T. Fine. So you calculated, that's straightforward, going to be 15 RT. So option number 3 would be the correct option for question number 17. Now it's time that we move to question number 18. Question number 18 has been put up from the topic of capacitor, and a basic circuit has been asked. It says there, in the figure shown below, the charge on the left plate of the 10 microfarad capacitor is minus 30 microcoulomb. So on the left is minus, so quite obviously on the right would be plus, and it's 30 microcoulomb. The charge on the right plate of the 6 microfarad on the right. So quite obviously, as per the given charge configuration, a distribution of this would be there. And now let's try to calculate it. And when I calculate this thing, see, one thing is very true, that the charge on the right plate is going to be a positive one. So these two options would be eliminated. Coming forward, if I want to calculate it, let me call this charge as Q1 and this charge as Q2. So since they being in parallel, Q1 by 6 would be equals to Q2 by 4. That's the first one. And then conservation of charge allows us to write Q1 plus Q2 is 30. The unit is in microcoulomb. Well, you solve these two simultaneous equations, you're going to get option number 1 as the correct option for question number 18.